Hello everyone, I'm going to show you something that I thought was particularly cool. If you're not interested in the code side of it, then once you've established what the video's about, you can skip to the end and see the result. But I'm going to go through the code of it in the middle of the video, so hope you enjoy it as much as I did. Well, here is a little interesting thing that just happened today, randomly. My friend Sean, who runs the Computer File YouTube channel, he sent me a picture of a waveform and effectively challenged me to extract the audio from the picture. And here's the picture that he sent me. This is him saying Computer File, which is the name of his YouTube channel. If you're not subscribed, go and check it out. So the first thing I did was put it into Photoshop to try and make it a bit cleaner, take out the grid, all this grid and all this background stuff. And then I wrote a little bit of code in Visual Studio using .NET Core, and I'll talk you through it here. Just defining what file I'm going to look for. This is where the file is. I open it as a bitmap. I then create a list of integers. I go through the bitmap from left to right. I then have two variables, which are the min and the max and min, which I initialize as 0 and 1000. And then I go over the height of each pixel. So as I'm working from left to right in the image, I go from top to bottom of the image, and I look for the brightness of the pixel. And if it's over half brightness, so basically if it's not the dark background, then I am looking to set the minimum value and the maximum value, and I do that with the mathmin and the mathmax function. So for example, if y is 0 and the minimum is 1000 and there's a pixel at 0, it's going to pick 0 because the minimum between 1000 and 0 is 0. But next time round, when y is 1, it will pick the 0 because y will already been set as 0, and if y hasn't been set, then it would pick the 1. And the same is true the other way around with the max. So I'm getting the minimum and the maximum pixel positions. So basically I'm getting the top and the bottom of each slice, each single pixel slice of the image. And then I add these minimum and maximum to my integer list, which is called values. This here is a little filter which I added in later, but this basically takes a moving average of the values. So I'm looping through all the values minus the amount of the filter, and I'm basically making the value an average of the next however many values I've got set in the filter. And this just takes out some high frequency noise. And then here is actually a text writer where I write all the values out in a text file because I wanted to plot them. This is actually a different wave that I did before, but yeah, this here is the numbers from that bit of code, and then I plotted it in a graph just to see whether it worked. And here I open a file for binary output, and I set some variables for the wave file header. I'm not going to go through all that now, but basically I write out the wave file header with the correct sample rate and everything like that, and the bit rate. And then I go through all of the values and I write them to the file byte by byte. This here normalizes the value to make it fit between 0 and 255 because there's 256 different levels in an 8-bit signal. And then this here basically stretches out the wave. So I define here how much I want to stretch the wave because we don't know how much the photo's been zoomed in on. So in this particular example, I'm stretching by a factor of 9. So for each data point, I go round 9 times, and I'm creating a new value, which is basically going to be x over whatever the stretch is, multiplied by the value, plus 1 minus x over whatever the stretch is, multiplied by the last value, which then gets set here. The value gets then put into the last value. So when x is 0, you're getting none of the new value, because it will be 0 multiplied by v2. But as x grows and becomes the same as the value of stretch, so when it becomes 9 over 9, this becomes 1, and you're getting all of that value. And then I've got the inverse of that the other way round, so I've got 1 minus x over the stretch length. So this here, when this is 0, this will actually be 1, and it will multiply the last value by 1. But then as x increases in the loop, this will rescind to 0, and this will go up to 1. So that fills in the data in between the data points, and then when you run it, I've already run it, but when you run it, it converts this photo to a WAV file, and it looks and sounds a bit like this.
Computer file.
I'll play that again.
Computer file.
Pretty cool, huh? Anyway, just thought I'd share that with you.